All right, guys, I'm going to cover just the first part of chapter 3. So, when we look at isotopes, they're actually atoms of the same element that have different masses due to different number of neutrons. So, if I look at carbon, carbon has several different isotopes that we've talked about in the past, especially with biology. So the main one that we have is carbon 12. We have carbon 12s that make up our body, but we also have a lot of carbon 14. If you remember, carbon 14 is radioactive and very unstable, but we use carbon 14 to do radiometric dating on all carbon-based life forms. So in this case, when we're looking at it, carbon, and we're comparing carbon 12 to carbon 14, we know that there's more neutrons in a carbon 14 atom than there is in a carbon 12. Now, you know this based on taking the mass and subtracting the atomic number, and from that we can understand the number of neutrons are different. So in carbon 12, we take 12 minus 6 because carbon has 6 protons, and then that would be 6 neutrons. But in carbon 14, we take 14, subtract 6 protons, and we actually have more there, and so the mass is more, and so otherwise known as unstable. And that's just an example of an isotope. And of course, what we call these isotopes is a nuclide. And so those isotopes are designated with certain mass numbers. Okay, but we actually have two different designations for them. The main one is just we do a hyphen, and then the hyphen is followed by the mass number. So in this case, I'm using hydrogen. Hydrogen 1 is the actual isotope that's found on the periodic table. It's the neutral version of the atom. But the two isotopes following that are H2 or H-2 and H3 or H-3, meaning that there's also an isotope of hydrogen that has a mass of 3, and there's an isotope of hydrogen that has a mass of 2. Okay. So then there's this video. If you do not exactly remember what an isotope is at this point, because some of you I've had in class previous years and some of you I have not. And so at this point, please, if you do not remember what an isotope is, this is a great time to watch this video that I have linked here for you. So moving on, there are things called atomic masses, right? So we label that as AMU, atomic mass units. It's exactly 1/12 of the mass of the carbon 12 atom. The carbon 12 is neutral. And then we have the average atomic mass, which is the weighted average of all the isotopes combined. So for example, to find hydrogen, and everybody asks, how do they get those smaller numbers? For example, hydrogen is 1.008. Where does that 1.008 come from? Well, you take the mass of all 3 hydrogen isotopes, so hydrogen 3, hydrogen 2, hydrogen 1, add those all up, divide by 3, and that's where that 1.008 comes from. There's actually a table in your book, table 4 on page 82 of your textbook, that does a little bit of describing where those average atomic masses come from. So you can kind of think of it like this. So if I was to find the average of all my science textbooks, right, I actually have to weigh each individual textbook. For example, I have to weigh the biology book, then I have to weigh the chemistry book, then I have to weigh the physics book. I add all those weights up and divide however many books I have. So in this case, say I teach 5 different classes. I have 5 book masses. So I divide by 5, and that number is going to be my average weight or my average mass of all of my science books. Okay, and that's kind of thinking of that example. That's how they find the average atomic mass for each element. So then we have to think of, okay, how much matter makes up a unit of this element, right? And so we've designated as the mole, M-O-L-E, or the mole, M-O-L for short. It's literally a certain amount of a substance, so it has the same number of particles as 12 grams of carbon-12. Okay, so we can kind of relate that to a dozen eggs, right? So I know when I go to the store, I'm buying 12 eggs are in a dozen, right? And so if I buy 1 dozen, I know I have 12 eggs. If I have 12 eggs, I know I have a dozen. And so that's literally the concept of a mole, is like, okay, how much of each element is 1 mole, right? How much if I need a mole of a substance, how much do I need? And so that's based off of 12 grams of carbon-12. And we'll talk about more in a couple days. But then we get to what's called Avogadro's number, right? Amadeo Avogadro actually was looking at the number of molecules and the number of atoms in these elements and in the substance and in our bodies. And so he didn't realize that he was onto something until shortly after his death, someone said, hey, this number makes sense. And it comes out to 6.02 times 10 to the 23rd. And so that's literally the number of particles in 1 mole, 6.022 times 10 to the 23rd. So now if I know I have 1 mole of something, I know exactly how many particles, how many molecules, how many atoms it actually has. Okay. So when we're looking at this, we get to the concept of kind of combining those two things, and we have what's called the molar mass, the mass of 1 mole of a pure substance. We actually are looking at just the element, okay, or just the compound. And so we use this average atomic mass that's found on the periodic table, with changing the units a little bit, to find the molar mass. Okay, so yes, you'll need your periodic table for this in that packet that I gave you, or there's a periodic table in your student handbook on page, I think it's 135. Yes, on page 135 of your student handbook, you can also find a periodic table. Okay, so to find, for example, the molar mass of an element. So the molar mass of an element, I'm just going to look on my periodic table here in front of me and say I need to know the molar mass of 1 mole of hydrogen. Okay, so I'm going to look on the periodic table. 1 mole of hydrogen is 1.008. If I need 1 mole of lithium, right, it's going to be 6.941 grams per mole. If I need 1 mole of boron, it's going to be 10.811. If I need 1 mole of carbon, 12.011. So if you're following along on your periodic table, you'll notice that 1 mole of each element is already listed on the periodic table as its own mass, right? So now to kind of make it harder is finding the mole of a compound. So find the molar mass of calcium chloride. Calcium chloride, you should know, is rock salt. We put it in on the roads in the winter to melt the ice. So I'm going to look on my periodic table. I'm going to find calcium. Calcium has a mass of 40.078. That is grams per mole. Chlorine's mass, I can look on the periodic table, 35.453 grams per mole. And what I do is I add those two together. So I know that calcium chloride has a total mass of 75.531 grams per mole. So there are 75.531 grams in every mole of calcium chloride. A second example here is if I'm trying to find the molar mass of the compound lithium bromide. So lithium has a mass, if I look on the periodic table, of 6.941 grams per mole. Bromine on the periodic table, the mass is 79.904. And so what I do is I just add those two together, and it comes to 86.845 grams per mole. Now, you got to watch out for subscripts because you need, say, for example, this was LiBr2, then, of course, I would take that bromine mass times 2 and then add it to the lithium. So be careful there. All right, just some review here. Make sure you know your definitions, Dalton's atomic theory, Rutherford's experiment, Avogadro's number, determine the number of protons, electrons, and neutrons of an atom. And of course, you need to know your mass numbers. All right, that's it for this section. If you have questions, please send me an email.